Hey students, it's Mrs. T again, and today I'm going to talk to you about atmospheric moisture, chapter 6. Harry is here helping me a little bit, so I will see if he doesn't bother us too much as we talk about chapter 6 in our textbook in the 12th edition, atmospheric moisture. We are going to continue with our link between the atmosphere and the hydrosphere, right? So in the last set of lessons, we started talking about currents and ocean upwelling and the way that heat transfer happens within the oceans. And now we're going to talk about water vapor, ice, liquid water in the atmosphere. And so that is what chapter 6 is all about. We're actually not going to do all of chapter 6. I've given you some page numbers to read, and you can find that in our Blackboard class, set of lessons that goes with these topics. And what I'm going to talk to you about in this introductory video, you'll have 3 animated videos that are curated that go along with this content. They're required as usual, but in this video I wanted to go over some of the very basics that you need to know and keep in mind in the water cycle. They are going to eat the Amazon driver. I hope not, but they think so. So anyway, okay, so you see on the screen behind me this graphic that is essentially, it's phases of matter, or the different states of matter. As you can see in the center of it, it says states of matter. And so this is true. I chose this particular graphic to show you because water is matter, okay? And so you will see in the textbook, and you'll see other graphics that you might find when you're searching online, you'll see phases of water or phases of matter. I chose the word states. They all mean the same thing. The point is, we're going to talk about how water specifically in this chapter, we're going to talk about water is the form of matter that we're going to investigate. And so of course we know water most commonly in its liquid form, and maybe in its ice form, right? Or any kind of liquid that we freeze becomes ice, iced coffee or something, or lemon juice that you can freeze, or something like this. So of course that is a phase change, what we call a phase change, or a different state that liquids can have. And so liquid water, of course, has a wide variety of temperatures. At 32 Fahrenheit it freezes. Actually it begins to freeze a little bit sooner than that, and then at 212 it boils and evaporates, but evaporation is actually happening all during the liquid phase of water. So here's Harry again. Okay. So what this chapter relies on is that you have a basic understanding of this process, this heat transfer, energy transfer, absorption, release process that happens in the hydrologic cycle, or the water cycle, as you will hear it called also. So of course, there's a lot of different processes here. I've used a word, evaporation. And so evaporation happens, well, when you sweat, for instance. One of the reasons that you sweat is because evaporation is a cooling process. So when you sweat, that water, that liquid that comes on the surface of your skin, the goal is for it to evaporate from your skin so that the energy, the heat energy, is absorbed into the atmosphere from your body, so you can keep your body cool. To the contrary, when something condenses, like if you have a cold cup of iced tea or something, and you set it down and there's like a little ring on the table underneath it, it's not leaking out of that glass. It's not, seeping through holes or something in your cup. It is condensing. It is absorbing energy out of the air and condensing it around that colder substance. The air around it is warm, it holds water vapor, and when the temperature changes for that air, the water vapor is going to change also. It's going to condense on something, around something. I remember when I was small and I was learning about evaporation, condensation, sublimation, which you see on this graphic. This was just a fascinating thing for me. I liked to see the properties of water, the way that water behaved when it was in droplets. For instance, I would sit on car trips and it would be raining, and you'd see the water like run down the window, the exterior of the window, and it would hit another water droplet, and it would get bigger, and another water droplet, and it would get bigger, and then the way that it went down the window would change. The bigger and bigger the water droplet became. And that's a property of water. Water is sticky. That's a property of water that you will learn about in this chapter. We say water is sticky because of something called a hydrogen bond. This means that the molecule of water, things are attracted to it. It's one of the reasons why water is considered a universal solvent. You can dissolve almost anything in water. There are some things that won't mix with water, but you can dissolve almost anything. It's a universal solvent. And so the properties of water are fascinating and really vast. And that's one of the things that you'll see from the very beginning in this chapter is the fact that there are so many concepts covered. You'll have like with this concept in 2 or 3 paragraphs to describe it, and another concept in 2 or 3 paragraphs to describe it. And now I've got Pudgy here with me, helping me with the water cycle. Anyway, so these things are also represented in different graphics. In addition to this one that I'm showing you in this video, there's different graphics for you to use to learn and to understand all these different concepts that are vital in the way that our atmosphere, our hydrosphere, our atmosphere, and our biosphere work, right? These things are all intimately linked, and life on Earth is really reliant on water. One of the things that people who are investigating outer space, life on Mars or the composition of the atmosphere on other planets, the very first thing they look for, water, evidence of water vapor, because it is such a vital part of our existence. Water vapor is one of the vital greenhouse gases, which you might think of. Some people in the past, when I've taught this class, have said, oh, greenhouse gases, those are bad. No, those are vital to our system, our biosphere, and our hydrosphere that we have here on Earth. So make sure that you investigate why. This chapter in the textbook explains that, and actually two of the 3 curated videos that you're going to watch gives you some of that information. But water is fascinating and vital. These are the major themes that you need to take away from this introductory conversation that you and I are having. And it's all around us all the time. I'm sitting outside right now. I hope that the wind isn't too noisy in the video, but one of the reasons I'm doing the video out here is because the clouds in the sky, I just wish that you could see them. There are such wonderful clouds in the sky, and there's different types of clouds in the sky at the same time, at different levels in the atmosphere. And this is one of those days where it is easy to tell where this cloud, what part of the atmosphere this cloud is in, and how high another cloud top is compared to the next one. And so these clouds are made up of water. They are made up of condensed molecules of water vapor around nuclei that are in the air. A nucleus is something that water vapor can condense around, either condense in liquid form or condense in ice form, solid form. And that's what eventually, with enough instability and heaviness around those condensation nuclei, that's what can cause precipitation. That's what does cause precipitation. And so, wow, there's just so much to cover in this chapter together, and I hope that the curated videos that provide you with some lessons and graphics and explanations will make some of the information in the textbook more clear and more real to you. In my opinion, this chapter is just way too dense, and it doesn't really, this is an introductory class, but this chapter doesn't really give us, I don't know, the meat and potatoes that I want to chew on when we're talking about this kind of thing. But maybe that's just me, because the hydrosphere and the hydrologic cycle was really the thing that interested me the most when I was studying this in school. way back when I was you and somebody else was me. Yeah, that's how it went. Anyway, so look at this states of matter diagram that's on the board behind me. Look at all of the different words and processes, the blue arrows compared to the red arrows. We're talking about absorbing energy or releasing energy. This is all part of the Earth's heat transfer system that you're going to be asked about on unit assignment 2 that's coming up in another couple of days. And so this information is going to be helpful for you, not only just to understand the reality of the atmosphere and weather patterns and the clouds in the sky and why you have to wipe water off of you with a towel because it's sticky to your skin from hydrogen bonds, just from how vital water is in all aspects of life. We are made up of water. Our bodies are 60 to 80% water. And just read in your textbook how much of the world's surface, the surface area that you can observe from outer space, just look at how much of the Earth's surface area is made up of water. And so that's a big deal. We have to understand this very intimately in order to really do our diligence about understanding physical geography this semester. So this won't be the only time I'm talking to you about the water cycle or the different processes that occur within it. So I suggest you get your textbook out, look at all the different topics and headings for the different sections that are found within those pages of your reading assignment. Take a nice ice cold cup of something. Don't put it in a Yeti or any kind of insulated cup, but put it in a nice ice cold cup of something. Go outside where it's a little bit warmer. Check to see whether there's condensation on that glass after a little while. Look at the clouds, see how they're moving, and make some of those connections about how the cells of the atmosphere and the air move, and the jet stream and the high and low pressure systems and fronts, as we will cover in future lessons. All these things are connected, and we're really getting a lot of meat on the bones of our just basics that we've covered so far. We're getting down into the nitty-gritty, so this should be fun. This should be it's fun for me anyways. I hope you can tell I like these topics. So this should be more in-depth and more challenging, these chapters as we move forward. Okay, text me with questions. Bye.